Welcome to Lesson 05. Today we take a fundamental step forward, mastering control flow. Up until now, our scripts were static sequences of commands. But today we start giving our code the ability to make decisions and repeat operations autonomously. The objective of this session is to master conditional statements for handling different scenarios and to learn how to use for and while loops to automate repetitive tasks. These tools are the true engine of any modern software. Control flow defines the order in which instructions are executed. Without it, a program would simply read data linearly from top to bottom, unable to handle exceptions or variations. In practice, it's what makes software intelligent. Conditional statements allow your program to branch out. Think of it as a fork in the road. The code chooses which path to take only if a specific condition evaluates to true.
Take a look at the example. We set the variable age to 20. Line 2 checks if age is greater than or equal to 18. Since this is true, Python executes the first print and completely ignores the else block. If we had set it to 15, the terminal would have printed minor instead.
Often, two options aren't enough. To handle 3 or more scenarios, we use elif, which is short for else if. This allows us to create very precise chains of logical checks.
Exactly. Here we evaluate a score of 75. Python checks the first line, it's false. It moves to the elif on line 4. Since 75 is greater than 60, it prints past and stops. It's important to understand that once a true condition is found, Python skips all subsequent checks in that block.
Every condition is based on Boolean expressions. We use comparison operators to check for equality, difference, or magnitude. The result will always be either true or false.
In the table on the left, you can see the standard operators. Notice the double equals sign for equality. Don't confuse it with the single equals used for assignment. In the code snippet, printing x greater than 5 returns true directly to the terminal.
Unlike other languages that use curly braces, Python uses indentation to define code blocks. This isn't just about style, it's a strict syntactic rule.
Look closely at lines 2 and 3. They are indented relative to the if. This tells Python that both lines belong to that specific block. If you were to align line 3 with the start of the margin, it would execute every time regardless of the condition, causing logical errors.
A for loop is the ideal tool when we know in advance how many times we want to repeat an action. It's perfect for iterating over numerical sequences or collections of items.
Here we use the range 5 function. Pay attention, in programming we often start from 0, so range will generate 0, 1, 2, 3, and 4. The loop executes the body for each of these values, printing them in sequence.
The power of the for loop lies in its versatility. We can iterate over lists of complex objects or even analyze every single character within a string.
Look how simple it is. In the first example, Python takes each fruit from the list and temporarily assigns it to the variable fruit. The same happens with the string Python, where we print one letter per line.
A while loop keeps running as long as a condition remains true. It's used when we don't know exactly how many iterations will be needed, like waiting for a specific user input.
In this code, as long as count is less than 5, the loop continues. Line 4 is crucial. We increment count by 1 during each cycle. Without this instruction, the program would never know when to stop.
Sometimes you need to exit a loop early or skip a specific step. To do this, we use the keywords break and continue.
With break, we stop everything. If I reaches 3, the loop closes immediately. With continue, however, we only skip the current turn. If the fruit is banana, Python goes back to the start of the loop without printing, moving directly to the apple.
Beware of infinite loops. They are a programmer's nightmare. They occur when the exit condition never becomes false, causing the entire application to hang.
Look at the error on the right. X starts at 0 and the loop checks if it's less than 5. But since we never change the value of X, the answer will always be yes. The program will keep printing forever until you force it to close.
Loops can be nested, meaning one inside another. This is essential for handling complex data structures like matrices or database tables.
It works like this. For every single cycle of the outer loop, I, the inner loop j must complete its entire path. In this example, you'll see combinations of coordinates printed, as if we were reading cells in a grid.
Which one to choose? The golden rule is, if you know how many times you need to iterate, use for. If you depend on an external condition that can change at any time, while is the right choice. In data analysis, control flow allows us to clean datasets, transform values conditionally, and create statistical simulations. It's what turns raw data into useful information. Great job! Lesson 05 is complete. You have just acquired the logical tools to build dynamic programs. In the next lesson, we'll see how to make your code reusable with functions.
Put what you've learned to the test with the exercises on michellepieri.com. Writing loops takes practice, so don't skip the tests. See you in Lesson 06.